question yedu yekutanga iri kuti a curve has equation y is equals to x cubed plus 3x squared minus 9x plus k, where k is a constant. So the first thing we want to discuss, zvinorevei kana tichiti k is a constant. So we have to know, but before we get into it, the color coding of this exercise, zvandichanyora with the color white, ndizvo zvinhu zvamunotarisirwa kunyora in your examination or test, but zvandichanyora in different colors, it's there for illustration. So k is a constant. The word constant, what does it mean? It just means unchanging. Kuroti k hasi kuchinja. Saka from this phenomena where we are saying k is a constant, this simply means k is going to be an element of real numbers. In simpler terms, k is a real number. In most simpler terms, k ingori number. It's a constant. And we have also learned kuti the derivative of a constant, cannot the derivative of any number, like what is the derivative of, for example, 2, what is the derivative of 5, etc. The derivative of minus 10, etc. is going to be 0. Take a differentiator, a number, an example, take a differentiator 3, take a differentiator 8, take a differentiator minus 100. The answer we get is 0. So we shouldn't be confused. Kana vakati k is a constant. What they just mean, simply putting it, vari kungoti k is just a number, and the derivative of that particular number, which is a constant, is going to be 0. So ndo pekutanga. Tapiwa that function y is equals to x cubed plus 3x squared minus 9x plus k. Tikapiwa kana kuudza kuti k is a constant. We now want to answer the first part. So the first part iri kuti write down an expression of dy dx. So how do we do this? So paku answer this particular question, yati write down an expression for dy dx, the first thing we do, tinonyora pasi kuti y ambori equal to chi. Saka we are just copying that y is equal to x cubed plus 3x squared minus 9x plus k, like that. Then chatauda kutsvaga, it's dy dx. So dy dx is equal to, what is dy dx equal to? As we already know from what we have learned, takati kana y iri equal to ax to the power n, zvoreva kuti dy dx is equal to a anodona yova an x to the power n minus 1. So that's what should be done. Saka 3 anodona yova 3x, then 3 wacho subtract 1 na 1 plus the same happens apo 3 multiplying 2 adona x to the power 2 minus 1 and minus 9 and apa pana 1, remember, saka 1 akadona, it's times 1, then chi kosara x or subtract 1, like that. Then panapa pana k apa, tanga chikona kuinyora takati k x to the power 0. Tichiziva kuti x to the power 0 zvakangofanana nekuti 1. Saka pana zvatachinja, kureva kuti pana painenge yachi plus k multiplying 0, then x to the power 0 minus 1. So zvandaita apa ndangoshandisa the longest way. Otherwise, differentiating simple algebraic expressions shouldn't be complicated like this. So I think I'm going to show it as a method number 2. Okay, so this is just going to be equal to 3x squared, then panapa it's plus 6x apo it's, since 1 minus 1 ichizova chi 0 and x to the power 0 ndi 1, saka pa inongoramba iri chi minus 9, then panapa any number times 0 it's 0, saka it's plus 0. Otherwise zvamanga muchigona kuita as a method number 2, manga muchigona ngoti y iri equal to x cubed plus 3x squared minus 9x, like that, and then you have that plus k. dy dx is just equal to 3x squared. So this can just be done 3 anodona, then we subtract 1 from 3, plus 2 akadona, achati times 3 over 6x, subtract 1 from 2, inongoramba iri 1, then apo it's minus 9. The derivative of a constant is 0, so we don't care. So this is the final answer, which you could have done this, but I discourage against an unnecessary complication. You should learn to do simple differentiation simply. Okay, so tatoita the first part, saka let us write our answer here. Maybe it's going to be material. The answer to the first part yanga iri chi, tikuita write down an expression for dy dx, kureva kuti answer yedu dy dx is equal to 3x squared plus 6x minus 9. That's our answer. Let us go to the second part of what we were learning. Saka second part tichaita say part number 2. Iri kuti find the x coordinates. Saka there are some words called keywords, and as is suggested by the term keywords, these are words which contain the weight of the question. Kuroti tikangoona those words, they are directives as to what we should do. So find the x coordinates of the 2 stationary points on the curve. Ma keywords edu panapa nde aya. Chekutanga tikutsvaga x coordinates and of what 2 stationary points. Actually ngoti stationary points ndo zvakakosha on the curve. The moment we see panzi stationary points, zvikangonzi stationary points, tinofanirwa kubva tatoziva kuti we have to write this statement. Statement yacho inoti at stationary points, this is what the statement says, at stationary points dy dx is equal to 0. And ndozvinoreva kana kuti zvinorebwa nekuti stationary point. So this is the conclusion we have to arrive at. And I can try to explain it, but let me just do the explanation quickly. I'm going to do it on this space. Zvanzi stationary point. Chinonzi stationary point ichi. So when we talk about a stationary point, we are talking about a turning point. And saka if we have a curve like this is the turning point, kana kuti stationary point, pamwechete ne this part pari kutena our curve. And we should know that if we were to find the gradient at this point, tichishandisa the O-level method of using tangents, this horizontal line is a gradient of 0. That is the explanation why at stationary points dy dx is equals to 0. We learned about this If you have an issue with it, revisit your notes. Otherwise, you can ask and I'll find other ways of explaining it. Saka at stationary points, dy dx is equal to 0. But to calculate dy dx part 1, remember, tikawana 3x squared plus 6x minus 9. So the moment that dy dx is equals to 0, we can simply take this value of dy dx, which is 3x squared plus 6x minus 9 totally equal to 0. So zvirungoitika panapa in essence, tati at stationary points dy dx iri equal to 0. But dy dx yacho tamboitsvaka, sata replace kuside kunoku, which is the left hand side, kana kuti kuleft kuna dy dx ne value ya dy dx 3x squared plus 6x minus 9 is equal to 0. That is how we find the x coordinates. So let us now simply solve this quadratic expression using, in most cases, factorization. Saka panapa tikadivide na 3, and because taona to have a common factor inopinda into each and every one of our coefficients. Saka panapa todivide futi na 3 apo na 3. Remember kuti even kuseri kwa cosine kuchadividwa na 3. Iyi ndiyo method iya yatakadzidza ku level yainzi kana kuti principle yacho yakafanana ne the method of clearing the fractions, where we have to, what do we have to do? We have to divide by a common factor every term inside the quadratic expression. Saka yama 3 anodamburana. 3 into 3 ndi 1 and into 6 ndi 2. 3 into 3 ndi 1. 3 into minus 9 ndi minus 3. And 3 into 0 ndi 0. Sapana pa tikusara tina x squared plus 2x minus 3 is equal to 0. Now we multiply the first and the last terms. Kuti 20 minus 3x squared and minus 3 times x squared. Don't make a mistake kukanganwa kumultiply because what this is a negative. Then what are the factors of minus 3x squared such that tika multiply ma factors here tunowana minus 3x squared, as tika ma adder tunowana 2x. Saka let us work with 3x na x minus 3x minus x ndi 2x. 3x times minus x ndi minus 3x squared. So let us solve this further. What it means is we are going to replace ma factors edu, tichi replace the middle term. Saka x squared plus 3x minus x minus 3 is equal to 0. Masona. If we bracket these two tikagadzira tikaisa ma brackets on our quadratic expanded expression, we see kuti from the first bracket we factor out x, tichasara tina x plus 3. We can verify x times x and x squared, x times 3 and 3x. Then we factor out minus 1 kunoku, tichasara futi tina x plus 3, minus 1 times x and minus x, minus 1 times 3 and minus 3. This is equal to 0. Then we group my terms are kunze into a bracket x minus 1, then x plus 3 is equal to 0, like that. Then tada iso manje tenge takuti takuti bracket ra x minus 1 is equal to 0 or bracket ra x plus 3 is equal to 0. Kurevei kureva kuti x are equal to 1 or x are equal to minus 3. This is the final answer. And saka from this point, if we are to be honest, from this point tichidzika, this was O level. Saka what's important is this particular statement. At stationary points, dy dx is equal to 0. Let us see our question again. Yet find the x coordinates of the two stationary points on the curve. Saka tenge tatopedza part 2, tatowana the two x coordinates. Ndi x is equals to 1 or minus 3. Ma coordinates acho ndi 1 na minus 3. So let us write our final answer kuside kunoku in the event we need it. Saka our final answer is x is equal to 1 or minus 3. Then tauda kuita our part 3. So it's easy. Easy kana tikango master the first statement. At stationary points, dy dx is equal to 0. Let us now look at part 3. Part 3 yati, hence find the two values of k for which the curve has a stationary point on the x-axis. Saka, we want to find the two values of k. Satuda tswaka ma values are k ari kupi uyu, for which the curve has a stationary point on the x-axis. And chakakosha panapa kuziva kuti it's on the x-axis. So let us explain on the x-axis kuti zvinorevei. Saka if we have an xy plane panapa, take it on something, remember on the table, and I think this is classical. The cat is on the table, cannot the cat is under the table, ku primary. On the table yairevei, under the table yairevei. Saka on x, zoreva along x, like this. Kureva kuti kana zvikanzi on x, and on x, zviri kungoreva kuti the value of y will be 0. And there's a simple way of seeing this. Tikati ngatitsvagei the coordinates of this point. X is a negative, ngatiti ndi minus 3, ko y ndiani ndi 0. Tika electa another point also, panapa for example. X ngatiti ndi 5, ko y ngari chi ndi 0. Saka on the x-axis, zviri kureva kuti y is equal to 0. That's a clever way of telling you kuti y is equal to 0. So what you can do as an intelligible person, the reason why we write small sentences in our working, we are communicating with the examiner, the marker. We are also communicating with ourselves. Saka ndiri ine hangu, the moment yandino discover kuti pakanzi on the x-axis, ndinobva ndati on the x-axis, ndakuto answer part 3, on the x-axis, comma, y is equals to 0. Saka on the x-axis, ndogona daiso ndesa semicolon doti y is equal to 0. Mapaona. Saka kana tati y is equals to 0, as kuno kutapiwa the equation, kana uti this is not an equation, it's a function. So tapiwa the function y is equals to x cubed plus 3x squared minus 9x plus k. Ndozva tapiwa. But pana patiri kuconclude kuti y is equal to 0. Saka since that y is equals to 0, but tichiziva futi kuti y is equals to x cubed plus 3x squared minus 9x plus k, logic should tell us kuti therefore x cubed plus 3x squared minus 9x plus k is equal to 0. That's logic. That's basic transitivity. Inoti kana a are equal to b, a zvakare are equal to c, zvinongoreva kuti b anenge equal to c. Basic transitivity. Don't worry about the big word. Doesn't matter. Just logic. Y are equal to 0. Y are equal to x cubed plus plus 3x squared minus 9x plus k. Saka x cubed plus 3x squared minus 9x plus k is equal to 0. Alright, let us continue reading our question. Question yet hence find the two values of k. Satruda utsvaga k and for which the curve has a stationary point. Saka chekutanga chatakuda kuziva panapa nchekuti and the values of x and the values of x kana kuti, let us write this kuti ive symbol, the x coordinates, yes, the x coordinates at stationary points akamira sei. So the x coordinates at stationary points akamira so ndi 1 or minus 3. X inge equal to 1 or minus 3. Handiti? Okay. Saka panapa zvanzi find the two values of k for which the curve has a stationary point. Saka kana curve rine stationary point kuri kuti tanga tadrawa an xy plane like this. Curve redu riripo somewhere panapa. Taudzwa kuti kana x ari 1 kana kuti minus 3 panenge paine ma stationary points. Saka let us just loosely imagine curve redu rakadai so. And it's just an imagination. Saka panapa it's a stationary point because it's a turning point. Then pana 1 panapa it's a stationary point because it's also a turning point. So isusu tiri kutsvaga value ya k kana x ari 1 or minus 3 because ndipo panechi ma turning points edu. I hope it makes sense. Saka kuti tichi tamadirira ngwe yacho panapa tinenge takudai so. Taziva kuti y iri equal to x cubed plus tapiwa this from our question. Taziva kuti y iri equal to 0 tikadijusa kuti x cubed plus 3x squared minus 9x plus k is equal to 0. Tiri kutsvaga k. But taudzwa kuti titsvage k when our function or curve is a stationary point. Kureva kuti where x is equal to 1 or minus 3. Satenge takungoti where x is equal to 1 and x pari equal to 1 pari kufamba sei. Totora the equation iro x cubed plus 3x squared minus 9x plus k is equal to 0. X pari equal to 1 kureva kuti we have to substitute 1 into that function, that equation. Saka pese pana x tichaisa 1 cubed plus 3 multiplying 1 squared minus 9 multiplying 1 plus k is equal to 0. Maonero kuti tazviitirei. Tazviita because question yedu iri kuda kuti titsvage k where the curve has stationary points and stationary point on the x-axis. Saka tiri kushandisa zvatawana from part 2 to help us get our answer. And we are going to see tichawana k say. Okay. Saka panapa, let us solve this. 1 to the power 3 ndi 1 plus 1 squared ndi 1, 1 times 3 ndi 3, minus 9 times 1 ndi minus 9 plus k is equal to 0, like this. Then trikutsvaga k, we can solve here and 1 plus 3 minus 4, 1 plus 3 ndi 4, 4 minus 9 ndi minus 5, so minus 5 plus k is equal to 0. Kureva kuti k iri equal to chi 5. Saka x pari 1 where x is 1 panapa x pari 1 k are equal to chi 5. That's important. Let us put a demarcating line panapa. The second part to this, tengeta kuti where x is equal to chi? Minus 3. X par equal to minus 3. We take this function x cubed plus 3x squared minus 9x plus k is equal to 0. Tati where x is minus 3, we have to substitute minus 3 into this function. Sakapayachi minus 3 cubed plus 3 multiplying minus 3 squared minus 9 multiplying minus 3 plus k is equal to 0. What is minus 3 cubed? 3 times 3, the 9. 9 times 3, 9, 18, 27. So this is minus 27, like that. Then upper, minus 3 squared into 9. 9 times 3, 9, 18, 27. So that's plus 27. Minus 9 times minus 3 into plus 9, 18, 27. Plus k, that's 0. Saka minus 27 at 27, this 0. It's just 27 minus 27. Tosarana 27 plus k is equals to 0. Kurewa kuti k is equal to chi minus 27. Like this. Saka x per r equal to minus 3. K anengari equal to minus 27. Like that. Okay. So, tapedza question. Hence, find the two values of k for which the kf has a stationary point on the x-axis. Apachi sina imwe demand. Kura kuti tinenge tangoya panapa toti. Therefore, k is equal to 5 or minus 27. Double underline. To miranza ku ZIMSEC. Toita 5 points.